Okay, we're live on track 3. We are the third group going, but we have some really good stuff. We're actually not starting with LLMs, which is exciting. We're going to start with computer vision today. We'll do some intros for our speakers today. We have Vasu Sharma, who's an applied research scientist at Meta, and we have Qasim Wanig, who's the CTO of Advex, and we're going to walk through, as you can see here, some synthetic data breaching the low data barrier in the industrial computer vision system. So very exciting, a little bit of a break from LLMs. We were really deep in the computer vision world a couple of years ago. Only the kind of cool kids were doing NLP. Now everybody's doing NLP, and only the cool kids are doing computer vision. So that's going to be really exciting to see. So we have two of the cool kids on with us. Welcome, both of you. Thanks for coming on.
I think we can just dive right in. More time for the demo, the better it is.
Alrighty, sounds good. Yeah, we'll focus on that demo.
Awesome. Okay. Awesome.
Whenever you're ready.
All right. So yeah, as we mentioned, a couple of cool kids trying to show you what synthetic data can get us. So yeah, we've been working with computer vision applications for a while, right? And one of the key problems, especially when you get off the academic research benchmarks and get into the real world data, is that you just don't have enough data, especially for the industrial systems. Like, for example, let's say you're trying to do manufacturing defect detection or trying to handle like mission critical use cases where you're deploying these to healthcare applications and stuff like that. You just don't have enough data. And even when you do, it's extremely hard to get the level of accuracy to make them valuable in real life, because even a small mistake can get you sued for millions of dollars, right? So you want to make sure that your application is foolproof. You have enough data to train these models to a level of accuracy which is acceptable in production. It's very hard to do this with real data. It's extremely slow to collect, extremely hard to label, expensive. But synthetic data, on the other hand, you can generate as much of it as you want. It's perfectly labeled the way you want it to. It's controlled and safe and compliant with all of your regulations. So in production, a typical life cycle of a product looks something like this. So you collect the data, which is extremely time-consuming, a very manual process. Then you have to label it, which is, again, like a whole round of expensive, very human-centric application. Then you train the model. Typically, the first round of deployment is never nice, with very little data, doesn't get the level of compliance accuracy that you need per se. And then you try to deploy it, but again, like, it's not good enough. So you can run into a lot of issues. The model degrades over time because as new data comes in, model's not getting updated. So you have to kind of keep retraining this model every 3 to 6 months, which again makes for a very expensive cycle where you kind of keep annotating, keep collecting data. And yeah, it just goes into this infinite loop where you just never kind of quite catch up with the production level accuracy. This is what the data typically looks like on a manifold. So you'll see that big cluster, which is pretty much majority of your use cases. But that's not the part that you care about. The part that you actually care about are those tiny dots that you see on the rest of the clusters. That's the hard to collect data. You get maybe one sample in a few months. And that's the sample which is actually mission critical from a production system lens, where if that sample you get wrong, it could basically mean for downstream fatalities. So you don't want something like that. So you want to bridge this gap and generate more of that data so that the model that you're training has good visibility into that level of data as well. And that's what Advex system helps you achieve. So it helps you generate these new data samples, which plugs in this low data regime and make sure that you have good representation on pretty much all of your classes, all categories, and even these mission critical data samples. We have a demo for you. So I'll switch it over to Qasim, who's going to walk you through a demo platform, which shows you how you can generate this for real life production use cases. Over to you, Qasim.
Sweet. Cool. Just 30 seconds overview on what we do, what the actual Advex platform does. So as Vasu put it eloquently, this data problem is very iterative by design. Companies collect a bunch of data, label it, train a model, only to see all the edge cases where it fails, and then they go back, recollect, relabel, retrain the system. And at Advex, our mission is to solve the data problem once and for all. And the way that we do it is through what we call an iterative workflow, where instead of you going and collecting this data manually, what if we convert generative models into data agents? What if we leverage the ability of these diffusion models in particular and have them be really powerful synthetic engines that can create high quality and diverse images? And what I'm doing right now is I've just uploaded a small data set for that one of our customers has this really big pain point where they want to detect for boxes on conveyor belts. This turns out to be a really, really difficult task, especially in low data regimes where collecting just as few as 100 images can take them several months. And what they do today is they upload the data on the platform, and this will take a couple of minutes. So I can skip to what this looks like. in some 2D manifold space, this is their image visualized. As you can see, there's all kinds of different images of packages on these types of what is known as a tilt tray. And in manufacturing, specifically, a tilt tray is this thing that if an object is of a certain shape, you tilt it right and it gets routed to a different part of the factory. If an object is below a certain shape or size, it gets routed to another side of the factory. And in this case, a customer had a lot of these examples. As you can see, there's a really big cluster, to Vasu's point earlier, that they don't really care about these types of images. The kinds of images that they don't have a lot of data for are the ones, if I can find that cluster here, over here. So these 4 specific samples, let me just zoom in here, are the 4 samples that they don't have a lot of data for. And what's special about this edge case is when you have one object, one box on 2 tilt trays. It's a really interesting manufacturing problem where what do? Do you move the tilt tray once, or do you move both of the tilt trays at the same time to reroute the box in a specific part of the warehouse? And this was a really, really big problem, which prevented them from deploying their models to production, which meant that they couldn't achieve actual automation. And with Advex, what they were able to do was very simple. All they had to do was select a region of interest that they cared about and describe what exactly are they looking for. And in this case, they're looking for a single object or more images of single objects on multiple tilt trays. And then they get to specify for a few other interesting things, such as the ratio between the real and Advex samples. In this case, we will 10x the data set size, and also how diverse of a data set should Advex generate. And we have done a lot of research over the last year around controllability of these diffusion models, where we can generate high quality but also diverse images. And once this is done, all you have to do is click this button, and then Advex will do its magic. And over the course of several hours, it will generate you the results. And let me show you what some of these results look like. So this is the run that I just uploaded, and this is a finished run. So this whole process typically takes several hours. And this is what a completed run looks like. This is the data that I just uploaded initially. As you can see, there's very few of these examples of object or this package and multiple tilt trays. And these are the corresponding segmentation masks. And over here, you see the Advex synthetic samples. So everything here is fully generative, both the images and the labels. And I can show you what this looks like here. And there's a lot more of these types of images. And you can see that there's diversity in terms of the color. The background is a little bit different. There's a lighting condition that has changed. But the results that matter the most are the following, the metrics. When the model, the customer model, was trained only on real data, their customer data, metrics such as IU was about 43%. And IU is one of the most canonical metrics used for evaluating computer vision tasks. But when they leverage our synthetic data that came from the platform in just 6 hours, that performance went up to 96%. In other words, we helped improve not just the model performance, but we actually took their systems directly to production in just 6 hours. And for this customer, which happens to be one of the largest camera companies in the world, for them to see similar gains, they would have to wait for 5 to 6 months. And that's really the value of synthetics, and the value of Advex is how can we reduce the time it takes to collect data by creating generative models and making these generative models really, really powerful. That's it for the demo. I don't know anything else.
I think we still have a few minutes left. So if we have questions, I think we can open up to the audience, or yeah, otherwise we can just give some time back.
Very unfortunately, my building has a fire alarm going off as we speak. This is
I hope you're okay.
Yeah, I think I'm fine, but I think that the audio is going to get really messed up right now. I'm sorry, one moment.
That's okay. As long as you're safe.
Kasim, if you can hear me at all, while we're going, why don't you give a little bit of background on how you got involved with computer vision and how you got the idea for this company?
Yeah, so I've been in the deep learning space since 2018 now, and similar to a lot of folks here, I spent a lot of my time across other very different applications, from AI for chip design to AI for drug discovery and to AI for energy systems. And the biggest problem that I encountered as someone in industry was that every time you build a deep learning model, what is the most important, what is the most fundamental prerequisite that you need? And that is access to high quality data. If you have data, you have AI. But every time I worked in industry, just collecting a handful of images would take us several months, $50,000 to $100,000, and a lot of frustration. And I want to minimize how much pain and suffering I would induce day to day. And so we started Advex about a year and a half ago to solve this fundamental problem in data collection. So in the future, ML engineers only have to select a region of interest. They no longer have to do all this kind of alchemy, which is beautiful, but at the same time costs a lot of time and resources. And I really do think that what we have at Advex is going to be a paradigm shift in how deep learning models will be developed, because these generative models getting so good and so powerful. Why not just use them as a synthetic training recipe from here on out for all computer vision tasks?
And how does the platform right now work an example for when you're generating data, giving the user the ability to say, like, these aren't good, like learn from these feedback loops and generate something that's more along the lines of what I need for alignment?
That's a really good question. So what I showed you earlier was this region of interest that you can select. You can also do the same thing once Advex has generated all the synthetic data. Once you have all the synthetic data that Advex has generated, it would also project all of those embeddings on the same screen. So you can say something like, hey, I really like these synthetic samples. I want more of this. Or I don't like a lot of these synthetic samples. Get rid of this for downstream training. And this is the true iterative workflow, where you get to just iterate with these generative agents and get better and better model performance, instead of you spending each iteration with Advex costs us 6 hours, but each iteration in the real world costs your customers several months. And there's still a lot, we're just scratching the surface here. There's a lot of research that we're working towards and unlocking, and synthetics is still a very nascent field. But this is what's really exciting is every model from here on out, I do believe, is going to be trained on some amount of synthetics.
Have you been thinking about, have you guys been, if you said this and I missed it, I apologize. Have you been training your own embedding models to get like deeper embedding understandings of these images, or are you using off the shelf models for the embeddings?
Right now, we do make use of off-the-shelf models. We are a startup, so speed is in our DNA right now. Right now, it's a combination of just leverage off-the-shelf models, but we have built a lot of core research around making these diffusion models in particular highly controllable. And that is really one of the biggest differences between LLMs and sort of the vision side, in which for LLMs, text is a really good interface of controlling and interfacing with these models. But for diffusion, you can't really justify what's happening in sort of this screen over here through a single sentence. It's really, really hard to capture the nuances and the details through text alone. But what if you make use of other features, some multimodal input like a segmentation mask on top of text, on top of other types of customer feedback? That is when you get really powerful, sophisticated generative models, and you really solve one of the holy grail problems of Gen AI, which is the hallucination problem. And that's one of the big research advancements that we've made over the last year is how do you make these models more controllable?
Yeah, I love that both from a technical perspective, but also from if anybody's watching here, there's like a technical how to get models into production, but there's also like if you're a startup trying to build a company and trying to be technical, even you guys who are like deeply advanced, cutting edge, you're still using off the shelf models. Like you don't need to just start your company by fine tuning a bunch of models. There's so much that you can get in the open source community, even honestly from the closed source models. Like you can move super fast and just focus on getting user feedback to build a company that leverages AI in new and nascent ways without having to start with crazy technical overhead. So I really like that.
I think understanding this model helps a lot as well. So I think one of the things these guys are doing really, really well is like they understand the core foundation of how these models work, take that off the shelf, modify it, do the research on top, and then customize it to the use cases which suit our needs. For example, the controllability part that Carson described, that's like a whole different ballgame. It's not in the off-the-shelf model. That's something that we added on top of existing models to bake that in based on obviously research techniques, but kind of combine that together. So understanding these models, understanding your use case well, and then bridging that gap, that kind of creates the delta there.
Yeah, I love that. Okay, we're only 1 minute over, so that was really good. Good thing we give 5 minutes of cushion. Is there anything you guys want to share? Like any final things for people to learn more? Check out websites. Check out your LinkedIn, GitHub, anything like that?
Kasim, you want to drop the website? So it's a self-serve platform. So if anyone wants to try it out for their own use cases, drop some data and see how it does for you. So you can provide some synthetic data points and then also share some benchmark results or some exemplar data sets and get performance on that. So yeah, it's very easy to try out. So yeah, feel free to give it a whirl.
Yeah,
I love
we
that.
still haven't given full GA access. We're still working with some of our enterprise customers, but we are hiring. So if anyone here is interested in some of the stuff that we talked about and has a background in ML, things like representation learning, diffusion learning, or diffusion modeling, would love to connect. I can share a job description here if that'll be helpful.
We got one question and we have 3 minutes. If you want to try to answer this one really quick. Said, fantastic demo. How do you ensure, this is kind of similar to what we talked about, but how do you ensure the quality of the data generated with regards to biases that are propagated? And from a product point of view, what are some of the specific use cases you're trying to target?
Yeah, from a product perspective, a lot of what we have seen, I mean, what we're solving is a very general deep learning problem. But the rule of startups is if you're good at 10 things, you're great at nothing. And so you really have to focus on things that are truly, truly important. And what we've noticed is that the world of manufacturing and the world of industrial automation more broadly are the guys that have the hardest time collecting data and productionizing AI systems. For some of these applications, collecting as few as 20 images takes them 6 months. This is, a nightmare for most people. Just a small handful of images would take some very long time. And the reason for this is because the kinds of images that they care about are things like defects, things like anomalies. Anomalies by design are rare. They're not happening frequently. And so if it takes you several weeks to collect a handful of images, just having a large enough data set to train one of these downstream models will take you a very, very long time. But manufacturing is all about revenue. It's all about how can I quickly automate myself? How can I quickly make more stuff faster, cheaper? And that's really where we see a lot of the value of Advex is helping these factories automate themselves, truly automate in a reliable way. And the world of manufacturing is huge. It's the backbone of humanity. Everything you wear, you use, it comes from a manufacturing process. If you just help these guys make whatever they do much faster through powerful automation, you've basically improved or elevated the baseline of humanity.
I love that. Okay. Thank you guys both so much for coming on.